Greeting learners, so we're gonna continue our session. Remember last time we were talking about arithmetic sequences. Now we're gonna talk unit 2, geometric sequences. A geometric sequence is a sequence of numbers with a common ratio between consecutive terms. So in general, we define a geometric sequence as follows. A is the first term, A times R is the second term, A times R squared is the third term, and A to the power of 3, dot, 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 and then the last one will be A times R to the power of n minus 1. A is the value of the first term, and the R is the common ratio between consecutive terms. R will be equal to T2 over T1 is equal to T3 over T2 is equal dot dot. Then we're going to have Tn over Tn minus 1. And then A to the power, A times R to the power of n minus 1 is the general term. So Tn will be equal to A times R to the power of n minus 1. Tn is the value of the last term. So let's consider an example. Consider the geometric sequence 5, 10, 20, 40, 80, and so on. Determine the nth term of this geometric sequence. Our geometric sequence is having term number 1, 5, term number 2, 10, term number 3, 20, and so on and so forth. So they want us to determine the nth term of this geometric sequence. Solution. We're going to start by getting the common ratio. R will be equal to 10 over 5, which will be equal to 20 over 10, and then you can see that our common ratio will be 2. And if we want to determine the nth term, Tn will be equal to, the first term is 5 multiplied by 2, the common ratio, to the power of n minus 1. So we're going to take now a worked example number 1, so that we can apply this concept of geometric sequences. Here's our worked example number 1. Consider the sequence 96, 48, 24, 12. First question, state the values of the next 3 terms. Question number 2, determine a formula for the nth term. Question number 3, determine the value of the 10th term. And the last question number 4, which term is a value of 3 over 64? So we're going to take the solution. State the value of the next 3 terms. We're going to take them. As you can see here is 96 divided by 2, we get 48, divided by 2, we get 24, divided by 2, we get 12, and 12 divided by 2, then we're going to get 6. 6 divided by 2, we're getting 3, and 3 divided by 2, we're going to get 3 over 2. These are the next 3 terms of a geometric sequence. Now we're going to question number 2. Determine the formula for the nth term. If we want to get the formula for the nth term, we will need the value of the first term, that is 96. we're also going to need the common ratio. Our common ratio here, how are we going to get it? I'm going to write it here. So formula R will be equal to T2 over T1 is equal to T3 over T2. And if I consider my geometric sequence, we'll be having T2 is 48 over 96 is going to be equal to 24 over 48. And this will give us 1 over 2. This is our common ratio. So now, to determine the formula for the n stem, we're going to write Tn is equal to A times R to the power of n minus 1. Tn will be equal to, the value of the first term is 96. We multiply by the common ratio, that is 1 over 2 to the power of n minus 1. So here's the formula for the n stem. We're going to question number 3. Determine the value of the 10th term. 10th term is term number 10. So we'll be taking the question number 3. T10 will be equal to, we're going to replace n by 10, and it will be 96 multiplied by 1 over 2, 10 minus 1, then we get 9. This is the value of the 10th term. We're going to take the last question, that is going to be question number 4. I'll clean the board here because we need some space for question number 4. As we have already responded to the first 3 questions, we're taking the last one, which term is the value of 3 over 64. Question number 4. So we're going to replace Tn by 3 over 64, and then we'll be looking for the value of n. So we'll write here 3 over 64 is equal to 96 times 1 over 2 to the power of n minus 1. Remember here, we are trying to get the position of this term. This is actually the question. Which term is a value of 3 over 64? So, to make it simple, we're going to multiply both terms by 1 over 96. So, this will be, then we're going to have 3 over 64 times 96 is going to be equal to 1 over 2 to the power of n minus 1. Meaning, if you multiply the left-hand side by 1 over 96, we'll be having 3 over 64 times 96. And the other side, 96 multiplied by 1 over 96, will be getting 1 here. Reason why, on the other side, we're having 1 over 2 to the power of n minus 1. So we're going to use our calculator, and this will help us to see what will be the value of n. Three over 64 multiplied by 96. Then we're getting here cleaning the board for us to have some space. Then we're getting 1 over 2048 will be equal to 1 over 2 to the power of n minus 1. So, in order for us to get the value of n, we need to express this 1 over 2048 as a power of 1 over 2. This is what we're going to try and see. 2 to the power of 12. 2 to the power of 11. Okay, so this will be written 1 over 2 to the power of 11 will be equal to 1 over 2 to the power of n minus 1. As you can see, we're going to equate these two, left and right side. So you can see that 1 over 2 to the power of 11 is equal to 1 over 2 to the power of n minus 1. This will imply that 11 will be equal to n minus 1, and our n will be equal to 12. So, t, the position of this term n is equal to 12, it means t12 will be equal to 3 over 64. So we have practically covered our work example number 1. We're going to see if we can still have time to go to the next example. Okay, so we are going to the worked example number 2. We have finished worked example number 1. Worked example 2. X minus 6, 2x minus 6, 5x plus 3 are the first 3 terms of a geometric sequence. First question. Solve for x showing all necessary calculations. Question number 2. If x is equal to negative 6, state the first 3 terms of a sequence and the nth term. Question number 3. If x is equal to 9, state the first 3 terms and then the nth term in the form Tn is equal. So we're going to the solutions. Question number 1, solve for x. Remember, we still gonna need to calculate to determine the common ratio. So for question number 1, we'll write R is equal to T2 over T1, and this will be equal to T3 over T2. I'm going to replace, so we'll be having that T2, 2x minus 6 over x minus 6 will be equal to T3, 5x plus 3 over T2, and that is 2x minus 6. I'm going to cross multiply in order for us to determine the value of x. So I think we will need some space. Let's see how we can get the value of x. So we are solving for x now. As I was saying, we're going to cross multiply. R is equal to T2 over T1 is equal to T3 over T2. We were having 2x minus 6 over x minus 6, and this was equal to 5x plus 3 over 2x minus 6. We are solving for x here. So by cross multiplying, we are getting 2x minus 6 squared. This will be equal to 5x plus 3 times x minus 6. 2x minus 6 squared, we're getting 4x squared minus 24. 12 times 2, 24x plus 36. This will be equal to 5x squared minus 30x plus 3x minus 18. So we'll be having 4x squared minus 24x plus 36. This will be equal to 5x squared minus 27x minus 18. So I'm going to take this to the other side to avoid the negative sign. So we will be having 5x squared minus 27x minus 18 it will be here minus 4x squared plus 24x minus 36. This will be equal to 0. Let's double check to avoid the mistakes. So I've considered the left hand side to the right hand side. We have been 5x squared minus 27x minus 18 minus 4x squared plus 24x and then minus 36. So here we'll be getting x squared minus 27 plus 24, then we're going to get minus 2x, and minus 18 minus 36, then we are getting minus 54. And this product will be negative 54. These two numbers are going to be negative 9 plus 6. Negative 9 plus 6, we're getting negative 3 as the sum. And negative 6 times 6, we're going to get negative 54. We're getting these two numbers in order for us to be able to factorize this trinomial expression. Then we'll get the values of x responding to the question if they're survey solve for x. So by using the grouping method, we will factorize this trinomial. X squared minus 9x plus 6x minus 54 is equal to 7. We're going to group x squared minus 9x plus 6x minus 54 is equal to 0. We'll factorize x here, x minus 9, and here we're going to factorize 6, x minus 4 is equal to 0. X minus 4 being a common factor, we will get to x minus 4 times x plus 6 is equal to 0. So here our two factors, and then x minus 4 is equal to 0, x will be equal to 9, and the other one is x plus 6 is equal to 0, x will be equal to negative 6. So this is practically the answer for the first question. They were saying solve for x, showing all necessary calculations. Here our necessary calculations. We having x is equal to 9 and x is equal to negative 6. So I'm going to clean the board in order to continue and go to the next question, that is question number 2. But I will need these 3 terms, our first 3 terms. It was x minus 6. The second one was 2x minus 6. And the third one is 5x plus 3. So I'm cleaning the board. It's okay. Okay, so the second question was saying if x is equal to negative 6, state the first 3 terms and the sequence and the nth term. So we got the value of x is equal to 9, and the other one is x is equal to negative 6. Or question number 2 is x is equal to negative 6. So if x is equal to negative 6, we'll try and get the first 3 terms. T1 will be equal to negative 6, we get negative 12, and T2 will be equal to negative 12, negative 6, we get negative 18, and finally term number 3 is negative 30 plus 3, then we get negative 27. So our common ratio will be negative 18 over negative 12. This will give us, divided by negative 6, 3 over 2. So these are our first 3 terms. And the nth term now, Tn will be equal to, if we consider the formula is a times r to the power of n minus 1. So our Tn will be equal to negative 12, this is the first term, and our common ratio is 3 over 2 to the power of n minus 1. Then we are done for question number 2. We're going to continue in our next session. Our first 3 terms are here, and our nth term is negative 12 times 3 over 2 to the power of n minus 1. We will continue with question number 3 in the next session. Subscribe, like, and get notified so we will be able to continue in the next session. Thank you.